Hi everyone! In the last video, we saw what a line looks like, and we learned about standard form, where ax plus by equals c, and a, b, and c are all integers, and a is non-negative. Today we're going to continue talking about lines, but we're going to look at two special places on the graphs of lines. These places are called x and y intercepts. So before we really get started, let's review what a coordinate graph looks like. Our coordinate graph has two axes, our x-axis that runs horizontally and our y-axis that runs vertically. So, x and y intercepts. X and y intercepts are points that fall on our line that happen to fall on the x-axis or the y-axis. So specifically, our x-intercept falls on our x-axis. So our x-intercept is our x-coordinate when y equals 0, and our y-intercept is our y-coordinate when x equals 0. So our y-intercept will always fall on the y-axis, and our x-intercept will always fall on the x-axis. Now let's look at an example of this. So we have our line in red here, running that way, and we can see that our x-coordinate, our x-intercept is going to be our x-coordinate where y equals 0. So y equals 0 all along this line, and when y equals 0, our line runs through the point x equals negative 2. So our x-intercept is x equals negative 2, and our y-intercept is where x equals 0. So x equals 0 all along this line, and our line passes through at y equals 3. So our y-intercept is y equals 3. All right. Now, before we move on, let's think about x and y-intercepts a little bit more. Do graphs of lines always have to have both an x and a y-intercept? I want you to pause the video and think about this for just a minute. Okay. So, let's examine this question by looking at two different graphs. Our first graph, graph number 1, has a vertical line running this way. And this line passes through the point x equals 5. So x equals 5 is our x-intercept. But the graph does not have a y-intercept because our line runs vertically. It only runs up and down. So our y-intercept does not exist. Conversely, in graph number 2, we have a line running horizontally, and our line passes through the point y equals negative 3. So our y-intercept is y equals negative 3, but we don't have an x-intercept because our line only runs horizontally. So in this graph, we don't have an x-intercept, so our x-intercept does not exist. And this tells us that we do not necessarily have to have both an x and a y-intercept. All right, so let's move on to some examples. Okay, so our first example has that 3x plus 4y equals 24. Now, we're going to solve for our x-intercept first, then we're going to solve for our y-intercept, and then we're going to graph our line. So before we learned that to solve for our x-intercept, we need to set y equal to 0 and solve for x. So let's do that. Let's rewrite our equation, but with 0 in for y. So we'll have 3x plus 4 times 0 equals 24. Now we know that 4 times 0 equals 0, so this cancels, and we are left with 3x equals 24. So 3x equals 24. And I'm looking to solve for x, so I'm going to divide both sides by 3, and I will be left with x equals 8. So our x-intercept is x equals 8. Let's keep that in mind. Now our y-intercept we're going to find by setting x equal to 0 and solving for y. So we will get 3 times 0 plus 4y equals 24. 3 times 0 is just 0, so we can cross that out. We are left with 4y equals 24. We can rewrite our equation, and I want to get y alone, so I'm going to divide by 4, and I will be left with y equals 6. So our y-intercept is y equals 6. So now let's graph these and see if we can make a line. So you'll notice on my graph, I numbered my axes by 2's because I know that I have rather large numbers and I don't want to draw that many points out. So I'm going to locate x equals 8 on my graph. And remember, this is going to be the point where y equals 0. So our point itself is going to be 8, 0. So that on my graph looks like this over here. We can check ourselves and make sure that this is indeed on our x-axis. Likewise, our y-intercept is at 6, so this is where x equals 0. So our coordinate point here is 0, 6. And I can find that on my graph up here. It is on the y-axis. And now I can easily connect these 2 points, and that will be my line. So I'll connect these two. Go straight through both and keep going. And that is my line. Straight there. All right, let's move on to example number 2. Example number 2 has x minus 2y equals 6. All right, so to find our x-intercept, first we're going to set y equal to 0. So we will get x minus 2 times 0 equals 6. And my 2 times 0 cancels out. And I will get x equals 6. Okay, so x equals 6 is my x-intercept. So I can box that. Now my y-intercept, I'll set x equal to 0. So I will get 0 minus 2y equals 6. All right, so I can rewrite this without the 0, and I will get negative 2y. Don't forget that negative there equals 6. And I want to get y alone, so I'm going to divide by negative 2 on both sides. And I get y equals 6 divided by negative 2 is negative 3. So y equals negative 3. So my x-intercept is 6 and my y-intercept is negative 3. So let's graph these. Now, remember this is where y equals 0. So my point is really 6, 0. So I can find that on my graph. This time my graph is numbered by 1's. So I'll roll over to 6, 0. And my y-intercept is at y equals negative 3 when x equals 0. So this is going to be 0, negative 3. So I can find that by finding it right here on my graph. And now I have 2 points that I can connect and make a line with. So I can connect these 2 points. And that is my line. All right, on to example number 3. This one's a little bit different. So here we just have that 3y equals 9. All right, so to find my x-intercept, usually I would set y equal to 0. So let's try that. And I want to solve for x. So let's rewrite our equation with y equals 0. So I get 3 times 0 equals 9. Well, we know that 3 times 0 is 0. So if I rewrite my equation, I get that 0 equals 9. But you and I know that this isn't true. So this means that I do not have an x-intercept. So my x-intercept does not exist. So we can write x-intercept does not exist. Okay, let's move on to the y-intercept. So my y-intercept is where x equals 0. Well, I don't have an x, so let's just solve for y using my equation. So I have 3y equals 9. And to solve for y, I can divide by 3 on both sides. And I get that y equals 3. So I do have a y-intercept, y equals 3. And remember, this is where x presumably equals 0. So this is going to be the point 0, 3. And I can find this on my line. So at 0, 3, going to be up here. And now, because I don't have an x-intercept, this means that my line runs horizontally. So I can draw a straight line through y equals 3. All right. Now let's talk about what these intercepts really mean. So we know how to find them from an equation, we know how to find them on a graph, and we know how to connect our intercepts so that our line is graphed. But what do these intercepts really mean? What's their purpose? Let's look at a few examples to try to figure this out. All right, let's look at some examples here and try to determine what our x and y intercepts really mean. So in this first example, we're talking about battery life of a phone. So on our t-axis here, now we're not talking about x-axis anymore. We can have different variables that stand in for x and y. Here we have t and p. So on our t-axis, we have the time that's passed since the last full charge, and this is in hours. And on our p-axis, we have the percentage of battery remaining. So if you'll notice, I have my axes here marked with 0.2, 0.4, all the way up to 1.0. If you remember, we express our percentages in decimal form by showing that like 20% is 0.2, 80% is 0.8, and 100% is 1.0. So that's what I mean with that axis there. So our line here goes from this point all the way over to this point, and I want to know, what do my x and y, or my t and p intercepts really mean? Well, let's take a look at the t-intercept first. So my t-intercept is going to be when our p equals 0. So when p equals 0, or when my percentage of battery remaining is 0, my t equals 16, or my time since the last full charge has been 16 hours. Well, this means that by the time my battery hits 0, I've gone 16 hours since my last full charge. Now let's look at the p-intercept over here. So our p-intercept is when t equals 0, so when the time since my last full charge has been 0 hours, so no time has passed since my last full charge. So that's going to be at 0, 1.0. And if you remember, 1.0 in terms of percentages is 100%. So what does this mean? Well, this means that when no time has passed since my last full charge, my battery remaining is 100%. This makes sense because when you wake up in the morning and you unplug your phone, almost no time has passed since you've had your last full charge, and your battery is at 100%. All right, let's talk about another example. This one is with temperature. So now we're going to have a c-axis and an f-axis instead of an x and y. So our c-axis is going to be our temperature in Celsius, and our f-axis is temperature in Fahrenheit. Okay, so let's look at our c-intercept first. Our c-intercept is at negative 17.8. So what does this mean? Negative 17.80 is my point. So this means that when my temperature in Fahrenheit is 0, my temperature in Celsius is negative 17.8. Likewise, with my f-intercept, I want to see when c equals 0, so that's going to be along this line, and my temperature in Fahrenheit at this point is 32. So this point 032 indicates that when my temperature in Celsius is 0, my temperature in Fahrenheit is 32. All right, so just to recap today's session, we've talked about x and y intercepts, we've looked at how to find them from our standard form, and we've looked at how to graph them. And remember, we always take 3 steps. We find our x-intercept first, our y-intercept, and then we graph. All right, thanks for watching. I'd like you to try these problems at the bottom of your guided notes, and I'll see you later.